Welcome to the DX Today podcast, your daily deep dive into the AI ecosystem. I'm Chris, and joining me as always is Laura.
Thanks, Chris. And I want to warn everyone up front that today's story sounds like pure plumbing, but it quietly rewires how every AI agent in production is going to work.
Plumbing is a hard sell for a podcast, so you're going to have to convince me early that this matters to people who aren't protocol engineers. And while you're at it, give us the 30-second version of what the Model Context Protocol actually is and why so many companies depend on it.
Fair challenge on both counts. Yesterday, July 28th of 2026, the Model Context Protocol shipped the largest specification change in its entire history. And the protocol itself is the standard that lets an AI application talk to outside tools, data sources, and services. Think of it as the universal adapter between a model and everything it needs to touch.
And it went from a niche Anthropic project to something the whole industry adopted remarkably fast, which is part of why a breaking change here makes a lot of engineers nervous. I also noticed the stewardship change, and I want to make sure listeners catch that, because governance shifts usually say more than technical release notes do.
You're reading it correctly, and it's the detail that tells you how seriously the maintainers are taking this. The spec no longer belongs to a single company. It now lives under the Agentic AI Foundation, which is a Linux Foundation-directed fund. Neutral governance means no single vendor can quietly bend the protocol toward its own product roadmap, which matters enormously once a standard is carrying real production workloads.
All right, you've earned my attention, so walk me through the actual headline change. And please do it slowly, because stateless is one of those words engineers say confidently, while everybody else nods along with no idea what was actually removed.
Happy to take it slowly. The headline is that the protocol became stateless, and 6 separate enhancement proposals worked together to rip out the entire session model that the previous November specification was built around. In the old design, a client had to open a connection and run a handshake first. The server handed back a session identifier, and every request after that had to carry it.
So it was like checking into a hotel. You get a room key at the front desk, and from that point forward, the key is what proves you belong there. Which also means the key pins you to one specific building, and suddenly your load balancer can't just send the next request wherever there happens to be spare capacity.
That's a good analogy, and it works fine when there's one hotel with one front desk. The problem is what happens when you try to run 40 front desks across 6 cloud regions. Teams were forced to build sticky sessions, shared session stores, and gateways that inspected packets deeply enough to route traffic to the one server holding your state.
And none of that infrastructure has anything to do with the actual job the protocol was supposed to be doing, which is connecting a model to a tool. So what does the new version look like on the wire? Something has to carry the information the server used to remember.
That's the whole complaint in one sentence. It was operational overhead imposed by a design decision that made total sense back when this ran as a local process on a developer's laptop. In the new version, every request is completely self-contained. The protocol version, the client identity, and the relevant capability flags all travel inside a metadata object attached to each individual request.
So instead of the front desk remembering you, you present your full credentials every single time you ask for anything. It's more verbose, but it's dramatically more flexible. And I assume that's what finally lets ordinary round-robin load balancing work without any special infrastructure underneath it.
Exactly right, and there's a genuinely clever detail alongside it. The spec adds 2 new headers that name the method and the tool being called right in the transport envelope where infrastructure can actually see them. A gateway can now route intelligently based on what operation you're performing without ever opening and parsing the request body.
That's why enterprise infrastructure teams are the ones celebrating loudest, I suspect. Rate limiting, routing, and observability all become ordinary web operations instead of protocol-specific special cases that require custom tooling. Nobody else in the building understands.
You've got it, and capability discovery, which used to happen during that handshake, moves to a dedicated discovery call. Clients simply ask a server what it supports whenever they need to know, and that request is just as stateless as everything else in the system.
Here's my devil's advocate question, and I suspect engineers listening are already shouting it at their headphones. Plenty of real tools genuinely need to remember things between calls. So where exactly did all of that state go?
Great question, and the answer is one of the most interesting design decisions in the whole release. State didn't disappear. It became visible. It moved out of the transport layer and into the conversation itself. Concretely, a tool creates something and hands back a handle. You call a checkout tool, it returns a basket identifier, and the model passes that identifier back as a normal argument on later calls.
So the model can actually see the thing it's carrying between steps, rather than relying on some invisible token buried in transport metadata that it has no awareness of whatsoever.
And that is a real upgrade, not a workaround. Angie Jones at the Agentic AI Foundation makes the point that a model can genuinely reason about a handle it can observe. It can compose handles, pass them between workflow steps, and explain what it's doing at each stage.
Which is better for debugging, and honestly, much better for anyone trying to audit what an agent actually did after the fact. But I sense there's a catch coming because that sounds a little too clean.
There is a serious warning attached, and I think it deserves real emphasis because most implementers will skip right past it in their eagerness to migrate quickly.
Let me guess where this is heading. If a handle is now an ordinary value floating through conversations, then a handle that grants too much power becomes a genuinely serious security liability.
Exactly her point. Handles must be scoped, validated, and expired properly. Otherwise, you haven't eliminated the risk at all. You've simply relocated it from the transport layer down into the application layer, where it's now your problem to design correctly.
That feels like the honest trade-off at the heart of this entire release. You get operational simplicity, but you inherit responsibilities that the protocol used to quietly handle on your behalf without asking you first.
Well put, and that same philosophy shows up in what got deprecated. 3 original core features are now formally on the clock, and one of those removals genuinely surprised a lot of longtime users.
Give me the list, and tell me which one made the community actually stop and argue about whether it was the right call, because that's usually where the interesting design debate lives.
Roots, sampling, and logging are all deprecated. Sampling is the emotional one because it let a server request a model completion back through the client, and people built genuinely clever things on top of that capability.
Why cut something people clearly found useful? That seems like the kind of decision that needs a strong justification to survive contact with an opinionated developer community that has already shipped code against it.
Because it created a reverse dependency. The server calling back into the client's model made trust boundaries genuinely hard to reason about, especially once servers moved into remote, multi-tenant environments where those boundaries actually matter.
So the guidance now is that servers should talk to model provider interfaces directly, which is simpler to secure, even though it costs you some portability across different providers.
That's the trade-off they consciously accepted, and I think it's defensible. The broader signal is that the protocol is deliberately narrowing its responsibilities rather than trying to own every concern that happens to sit near an agent.
Logging going away seems far less controversial, since the observability tooling that already exists is almost certainly better at that job than a protocol-level logging channel ever was going to be.
Right, and the migration path there is standard error output or open telemetry, both of which teams already run today. That's the protocol honestly admitting the ecosystem solved this particular problem better somewhere else.
Now, deprecation announcements usually terrify people, so tell me about the timeline. Because a breaking change with no runway is how you permanently lose an ecosystem's trust in a single release.
This is my favorite part, honestly. The release also introduced a formal deprecation policy requiring a minimum 12-month window before anything can actually be removed from the specification, tracked in a public registry with clear dates.
So nothing deprecated yesterday can disappear before July 28th of 2027, which gives every team a full year of runway and, more importantly, a predictable process they can plan around.
Correct. And that governance muscle matters more than any individual technical change here. They also now require conformance test scenarios before a standards track proposal can reach final status in the specification.
Why does the conformance suite requirement matter so much? On paper, that sounds like the driest possible process detail in an already fairly dry release announcement.
Because without shared tests, a standard slowly becomes whatever the largest implementation happens to do. Conformance testing is how a smaller project stays genuinely compatible instead of perpetually chasing someone else's behavior and always arriving late.
That's an argument against vendor lock and dressed up as a testing policy. And I'd argue it's actually the most strategically important sentence in this entire conversation.
I completely agree, and there are 2 new extensions worth mentioning before we wrap, because they hint at where agent interfaces are heading over the next year or 2.
Go ahead, but keep them tight, because we're running long and I want to leave people with a clear takeaway rather than an exhaustive changelog reading nobody asked for.
The first lets a server ship interactive interfaces that render inside a sandboxed frame right in the chat. So users can work through a form or a dashboard without ever leaving the conversation they're already in.
And the second one handles long-running work, which has been a genuine pain point since the very beginning, because synchronous tool calls simply fall apart when an operation takes 20 minutes to finish.
Exactly. Servers now return a durable task handle. Clients pull it for progress, send input mid-flight when a human approval is required, and cancel the work entirely if it's no longer wanted.
The durability piece seems important. If that handle survives a dropped connection, then a crashed client can reconnect and pick the work back up instead of starting over again from scratch.
That's designed in deliberately. And notably, the ability to list all tasks was removed. Because without sessions, there's no safe way to scope which tasks actually belong to which caller in a shared environment.
I like that they chose the safer design over the convenient one. That's a small decision, but it tells you something real about where the maintainer's priorities sit right now.
One last piece I don't want to skip because it's the one enterprises actually asked for by name. Authorization got substantially harder to get wrong, with stricter identity requirements now mandatory rather than merely recommended.
What does that look like for an organization that wants to deploy these servers internally, without their security team escalating the whole request straight to a hard and permanent no?
There's a new enterprise managed authorization extension. Administrators provision server access centrally through the company identity provider, so employees get connected automatically at login instead of clicking through a pile of individual consent prompts.
That's the difference between a technology security teams merely tolerate and one they can actively endorse, which is often the entire gap between a stalled pilot and a real production deployment.
You've landed on exactly why this release matters. Everything here points in the same direction, which is that agent infrastructure is being rebuilt for the people who actually have to operate it at scale.
So if I'm summarizing for someone who runs an engineering team, the message is to audit your servers now for hidden session dependencies before they bite you in production at the worst possible moment.
That's the practical takeaway. Find every place your server quietly remembers something between calls and turn it into an explicit handle that can be logged, scoped, and safely passed around by the model.
And the strategic takeaway, I'd argue, is that the agent ecosystem just grew up a little. Neutral governance, deprecation policies, and conformance tests are boring. And boring is exactly what production systems have always needed.
Beautifully said, and I'd add one hopeful note to close on. Open protocols get stronger when the strange edge cases surface early, and this release deliberately created the room for that to happen.
That's all for today's episode of the DX Today podcast. Thanks for listening, and we'll see you next time.